Okay, on this example, we've got a cubic function, and we're asked to label the relative max, relative min, and the inflection point, and then find the exact value of each point's x-coordinate. All right, so if I come over here and just eyeball it, this is the max. Notice before I put the dot there, the max is each one of these. How many do we have? How many divisions? 1, 2, 3, 4. So we've got 5 squares there, so each one of those is 0.2. So it looks like the maximum happens here. It looks like that's a little bit to the left of negative 1.2. The min happens over here, the relative min, at about 1/2. And the inflection point happens somewhere in here. Looks like maybe on this one, which would be at like negative 0.4. But let's work this out. First, let's find the exact x-coordinates of the relative max and min. So we'll take the derivative. F prime of x is 3x squared plus 2x minus 2. And we want to set that equal to 0 and solve. Now, I don't think this will factor. Why do I say I don't think it'll factor? Because those numbers didn't look like they were exactly on the dots over here. They don't look like they're exactly on the lines. So I don't think this will factor. So let's use a quadratic formula. We get minus b plus or minus the square root of b squared minus 4 times 3 times negative 2. All that over 2a. 2 times 3. Let's see. 4 times 3 is 12 times 2 is 24 plus 4 is 28. And that 28, you can break the 28 into 4 times 7. So this is minus 2 plus or minus 2 root 7 over 2 times 3. So it looks like my answers here are negative 1 plus or minus root 7 over 3. So that's my my relative max and min. So the relative max is at, let's see, the max was at, let's see, this point right here. That's the one that's minus 1 minus root 7 over 3. And the relative min is at x equals minus 1 plus root 7 over 3. And if you want to, we can, let's just check these. I'm going to stick them in my calculator and see what the decimal approximations are there. Minus 1 plus, or no, minus root 7 over 3. Yeah, that's like negative 1.21. 5. And then if I put the other one in, change that minus to a plus, that gives me 0.54. 0.549 roughly. So if you come back over here and look at these, they're pretty close. This one up here I said was looked like it was a little to the left of negative 1.2. And this one over here looked like it was about 0.5. And so those numbers look good. So it's nice that we use the graph to see what's going on, but then we use calculus over here to come up with the exact locations of the relative max and min. And if we wanted to find the value of the relative max and min, it would be simple. We just plug it back into the function here to get those y coordinates, but that's going to give us ugly numbers. Let's don't spend time doing that. Let's do the other thing that it asked. It said the inflection point. So let's find that inflection point. I'm going to erase this just to give myself a little bit of space. The inflection point will take f double prime. Derivative of this is going to be 6x plus 2. So we'll set that equal to 0 and solve. So we'll get 6x equals -2. So x is minus 2 over 6, where x is 1/3. So inflection point at x equals 1/3. And negative 1/3. So does that look right? Let's see, up here I drew my inflection point in just eyeballing it there. And it looks like I drew it in roughly at negative 0.4. And it's supposed to be at negative 0.333. So I'm not gonna move it, I'm just gonna leave it there. So we can see that, this is the exact value, and it aligns pretty well with the eyeball drawing. All right, so we'll stop this example here.